here is Precal problem 9-107. So it says two forces with magnitude of 120 newtons, I guess those are, and 250 newtons act on an object of negligible mass as shown in the diagram at right. So luckily it gave me a diagram. So the angle, it says determine the magnitude and direction of the resultant vector if the angle is 25. And then it has me do it for 45, for 65, and then it has me make like a, I don't know, it has me kind of generalize it for the magnitude. So I'm just going to do the first one and show you how. A word of caution, I had my little pink calculator and it was in radian mode. And I had to turn it into degree mode, or I had to put it in degrees because that's my first attempt I got wrong. So if you remember anything about this, when it says the word resultant, resultant means add. You must add the vectors, and you can only add them if they are in component form. Component form is when it looks like this. So here's my diagram. So if I put that on a just like a x, like on the, not the unit circle, but on an xy plane, I can get the ordered pairs that go with each vector. Like for example, this vector right here is just, it's going horizontally, and this is just, the x value is 250, and the y value is 0. So that's the component form of my first vector. I'm trying to add them because it said resultant, and resultant means add, and that means I have to add the one component form of the first vector plus the component form of the second vector. The second vector isn't that easy to get the component form. You have to do a little work for it. So what would be the ordered pair that goes with this point right here? It would be however far this x is, comma, however, high this y is. So if you remember, x is like, so this is the adjacent side of the triangle, and that's the hypotenuse of the triangle. So if this is a right angle, I can say the cosine of 25, and say cosine of 25 is adjacent, which is x, over hypotenuse. That's an x. And then I can multiply both sides by 120, and then I just get 120 cosine 25. And then I had to, you can see I did it wrong because I had radian mode, but then I found out that I did the whole thing wrong, and I put it in degree mode. So this gives me this side length right here, which is my component. That helps me get the x part of my component form, okay? And then how do you think I could get this length? Well, this is opposite over adjacent, right? Opposite over hypotenuse. Opposite. So I could say sine of 25 is y over 120, then I can multiply both sides by 120, and I get 120 times sine of 25 is 50.71. That gave me the y part of my component form. So now I have component form for this vector, and I have component form for this vector, and because it says the word resultant, that's why I am choosing to add them up. And when I add them up, I get these two numbers. This I drew on another XY coordinate plane. So this is actually this is the resultant vector. And it would be nice if they just would accept my answer in component form, then I'd be done. But they want the direction, or the magnitude and the direction. So now that I have this vector, which there's my vector right there, they're asking for the magnitude, which is the length of the hypotenuse, and the direction, which is the angle theta. So now I have to go back and find those. So I'm going to use Pythagorean theorem because I know that this vector, this is like x and y. I know this height right here is 50.71, and I know it's a right triangle, so Pythagorean theorem, 50.71 squared plus this length down here is 358.76-ish squared equals c squared. So I put that in my calculator, and then I took the square root, and I found out that this hypotenuse right here, 362.326, because of the way I rounded it, doesn't exactly match your answer book, but it's very, very close. So that is the magnitude. That's the magnitude. And then, so I've answered half of their question. They want the direction. They want this angle. Well, I can use inverse tangent. I can say tangent, because isn't tangent TOA? It's opposite over adjacent. So I have this number. This number is 50.71, and this number, this distance is 358.76. So tangent of opposite, or tangent theta is opposite over adjacent. And then, so I can inverse tangent. I didn't show that, but I can inverse tangent both sides. I just stick that in my calculator, inverse tangent of this fraction, and I get that as the direction. So this is the answer to letter A. Now, they asked me, and I did a lot of work for that. I did it the long way. But now I'm going to show you how, if you were to do this, how many more times? 2 more times, do that whole process 2 more times. It would take a very long time for you to do all that. But I think they're asking you to go ahead and do that again for these other two, just all the same thing, but just use a different angle measure. Use, instead of 25, use 45 and 65. They want you to kind of make a little generalization. So I'm going to just refer to the worked out solution manual that you guys have and see if we can try to make sense of it. So this is all that work that we did, that I showed you exactly where all this stuff came from. This was the magnitude. Remember, like we got it from a squared plus b squared equals c squared. So where did the a and b come from? So the 50.71, it came from 120 times sine of 25, didn't it? Oh, see? So they're just like showing it. Some of you guys might already be here where you're able to just like stick all these things right in your calculator. Like, did I have to draw all these diagrams? No. I mean, I did, but you might be able to just know what to do without having to draw all the pictures. But that's one of the sides, right? Remember, that's where we got this 50.71 came from. And then where did this number come from? The 358.76. Well, that came from adding the x components. So 250 plus 108, but the 108, that was 25, that was 120 times cosine 25. That's where that came from. So that's what this is saying. There's the 250, that's our 108 right there that we got. So that's kind of a generalization on how to get the magnitude. And then the direction, remember we used inverse tangent. We had inverse tangent of 50.71. Well, That 50.71 came from 120 times sine of 25, right? So right there, right? So basically what I'm saying is that instead of showing all their work, they're just kind of generalizing that. So that's the top of the fraction, because remember it's opposite over adjacent. And then that other side, you get it by going 250 plus. Well, actually, can't you just take it from right here? You can just take it, but once you do this top part, see this is the opposite side, and that's the adjacent side. So just take a look at that and notice that if they write it this way, all they have to do is swap out the angle measures. So this is that part where you're going a squared plus b squared equals c squared. It gives you the magnitude, and then this is the angle measure, the direction. So see that? So then in letter D, they ask you to make a generalization, not for the direction, but just for the magnitude. So you can kind of look at the three that you did previously, and you can say, oh, well, it looks like it's always 250, and then it's always plus 120 times cosine of whatever angle you want. So they just left it as theta. And then it's always 120 times sine of whatever angle you want to plug in there. And then they squared it out. So that's this is a binomial, so you'd have to go 250 squared plus 250 times 120 cosine theta times 2, that's this part, and then 120 cosine theta squared, that's this part. And then this is just 120 sine theta squared. So in other words, you had to FOIL this first part out. That's where all these terms came from. And then they noticed that they could factor out 100, because see how these all have 2 zeros in them, don't they? So you could factor out 100, but 100 is a perfect root, so you can take it out and simplify it as 10, and then you're left with this, right? Because you can, well, anyway, you're left with this. So that's what they wanted you to do. I hope that helps.